Welcome to my air engine research update. Thanks for checking in. And a special welcome to any new subscribers. And for first-time viewers, I hope you'll go back and look at all the videos that I've posted over the years. And it shows my attempts to design and hand build an air engine that is practical and efficient, that could power a compact car or a small pickup truck. But first, let me remind everyone that I am not a machinist or a professional engineer. Now, I do have a combination drill press and metal lathe that I bought from Grizzly, and it comes from China, and it's not very accurate. And also, I have an unheated two-car garage that I work out of, and right now it's just too cold to be doing anything out there. And as usual, it seems that there's always something that comes up to keep me from actually working on my projects. When I am working, though, I enjoy it. Sometimes it gets a little frustrating when I can't figure out how to do something. But so far, everything I've needed to do, I've managed to do. So I'll show you some of the pictures and videos that I've made over the years, and kind of up to date where I am now. I do have a, like I said, a combination mill press and drill press, and the lathe part is about a 2.5 foot with a 14-inch swing on it, so I can make something that's 14-inch in diameter. Anything that I have needed, I either got from the local hardware store, or I bought metal from a local machine shop, and then I would, work on whatever. I made videos of all the projects and the engines that I made. Some of them good, and some of them not so good. Let's see. When I think back over all of the engines that I made and built, I've come up with 2 of them that I think might be okay. When someone thinks about an air engine or an engine, there are a number of ways that you can use either gasoline or compressed air to make some sort of motion, and they all have some type of an output shaft. The crankshaft with lobes pushed by pistons, or some type of a rotary device turning a shaft. Compressed air doesn't need spark plugs, carburetor, or electrical system, but it does need a valve system to control the air to make it run. I tried a lot of different ideas, and one was a rotary engine, but the sealing on it was a major problem, so I just couldn't do that, especially with the compressed air that it uses, and you just can't afford to waste air. I started with cylinders and pistons on a crankshaft, and finally, after some years, now I have one that I think is pretty good. It's a 5-cylinder, and well, go to 3. Yeah, there we go. It's on a 5-cylinder engine mounted on the back of a converted lawnmower body that I put car tires on to make it the same as it would be as if it was in a small car or a pickup. It has a crankshaft that has 3-inch lobes on the 3 cylinders and 2-inch lobes on the first 2 cylinders. which makes it a total of a 5-cylinder. It can be run on 2 or on 3 cylinders or on all 5, but normally you wouldn't do that. The 3 of them, as you can see, they're on 3-inch cranks, and an engine with a 3-inch throw on the crankshaft, each piston has to go from top to bottom 6 inches. So if you've got 3 cylinders, that's going to be 18 cubic inches of compressed air for 1 revolution of the crankshaft. Now, I'm using a direct drive with a 3.25 inch ratio to 1, which, when you calculate that out, it uses 58.5 cubic inches of, or 58.5 inches, not cubic, but just inches of compressed air for 1 revolution. It does have quite a bit of power, and I'm happy with that, but with 5 cylinders and 2 valves for each cylinder, you can see it's pretty compact in there, and it's hard to get to. It would be very difficult with maintenance, and each of those valves has to be timed individually with the motor. Now, I've just got a little short video to show you how it takes off with the 3 cylinders. As you can see, it took off pretty good, but I had it on my air hose, so I couldn't go very far with it, and I didn't want to tear the air hose off my connection, so I shut it off real quick. But you can see it did take off pretty good. Let's see, after a lot of drawings and a lot more thought, I came up with another engine that I think would be okay. That one is a 3-cylinder with 1 1/8" pistons, and it has 2 plates that works on an eccentric to make the rotation. It has a straight drive shaft, and it only has a 2 1/4 inch stroke on the thing, so it only uses 6.7 inches of compressed air compared to that 58 inches on that 5-cylinder. And the overall size is about half of what the 5-cylinder is. So this is what that looks like, and the valve timing on it has only one setting for all 3. And if you wanted to, on the opposite ends of those push rods, you could add other cylinders that would be larger for more power if you needed it. And that would give you, well, either all 6, or you could run all 6 or 3 individually if you wanted to also. The video that I'm going to show you, it'll have just the 3 cylinders on it. And it's just setting on the floor, so when you see it move, come on. as you can see, that it goes pretty fast, and it's pretty well balanced up because it's just sitting loosely on the floor. The next one was, I've done a kind of a test in the actual vehicle, so you can see it run. Now my 3-cylinder doesn't have the power that the 5-cylinder did, and I need some kind of a transmission type affair, so I decided on using a chain drive, or a modified chain drive. Actually, it's no chain, but it uses some chain in it. It has an intermediate drive shaft. The engine will turn the intermediate, and the intermediate then would be hooked up to the axle by 3 individual idler gears that can be moved in and out in order to make contact with the drive
the wheel. So there'll be
That was a mess up. I'll have to get up to what I wanted to show you. There we go.
Drive gear over there. And as this is turned forward, it pulls into the drive gear. So it looks like it might work okay. I just have to put the motor on it and try and see if it does.
So that was my first intermediate idler drive that I put on. I'm going to have some type of cable or something that I can pull to engage with a spring that'll disengage when you let it go. But that's something I'm still going to have to work on. My air compressor tank is the next thing that I'm going to talk about. I have to have one to pull with the vehicle, and right now all I have is a propane tank. So this is my homemade trailer and propane tank that I use to pull behind my air-driven demonstration vehicle. It's a propane tank, and I pull it behind my vehicle to supply the air needed for moving around. It can go up to maybe 600 psi, but I can only get it up to 300 with my current air compressor. So until I can afford a carbon fiber tank and high pressure compressor to get it up to 4,500, 5,000 psi, I'll just have to rely on this for the time being. Okay, then the next thing that I had to come up with is a pressure regulator. I tried using commercial pressure regulators or air compressor regulators, but they won't allow enough volume to go through. They do maintain the pressure, but not enough volume. So I came up with a couple of ideas. One of them was a pressure regulator using a small air valve, which worked okay. The only problem is if for some reason the spring was pushed a little bit too far, or if something happened, the cylinder would push the valve open. After it once closes, it would go past, the closed position and back start opening it again, which I couldn't have that, because then it would just let wide open pressure into the engine, and that's no good. So the next thing that I did, I redesigned the thing so that it was built into a compact and much smaller pressure regulator, and that's the one now that I'm going to be using when I finally get everything put together. Eventually I'm going to need to buy a carbon fiber pressure tank. They are designed to hold up to 4,000, 5,000 psi, but the problem is they cost $4,000 to $6,000 a piece, and I just can't afford that right now. So I'll just have to do with, for the time being, with my propane tank. Well, I guess that's just about where I'm at today, so I guess I'll finalize this and say that it's been a while since I put one out. I thought maybe it's time I let you see where I'm at again. And once again, thanks for checking in, and for your new subscribers, I hope you will continue to watch, and when the weather gets a little better, I hope I'll be able to get out and get some of these things completed. So till then, thanks a lot, and I look forward to seeing you next time.